So with number 6, I start off with something like this. I have 2x1 minus x2 is equal to k1. x1 plus x2 plus x3 is equal to k2. And 2x1 plus x3 is equal to k3. Now this corresponds to the matrix equation. First I get the coefficient matrix by looking at the coefficients on my unknowns. 2, -1, 0, 1, 1, 1, and 2, 0, 1. And I'm multiplying that against the unknown matrix, x1, x2, x3. But here I'm also not given what the values on the right are. I'm just given, sort of some more unknowns, k1, k2, k3. But the book will eventually specify what these are supposed to be. In any case, though, I don't really care what these are for the very first step. The first step is just to find the inverse of this guy. And, I've done a number, why don't we just run through this quick? So I've got 2, -1, 0, 1, 1, 1, 2, 0, 1. This one isn't going to be too bad, it looks like. I want to make the left side look like the right side by using row operations. So the first thing I'm going to do is I'm going to swap rows 1 and 2, and that will give me 1, 1, 1. Remember, I've got to swap, I've got to do the same thing on the right side, so I get 0, 1, 0. And then I get 2, -1, 0, 1, 0, 0, and 2, 0, 1, 0, 0, 1. Now I'm going to add -2 row 1 to both row 2 and row 3 because I want to get rid of these 2's here and get zeros. So -2 times row 1 is -2, -2, -2, 0, and -2, 0. And what I end up with when I add that is I get 1, 1, 1, 0, 1, 0. -2 plus 2 is 0. -2 minus 1 is -3. -2 plus 0 is also -2. Let me erase that and make it look a little bit nicer. That's -2. 0 plus 1 is 1. -2 plus 0 is -2. 0 plus 0 is 0. -2 plus 2 is 0. -2 plus 0 is -2. And -2 plus 1 is -1. 0 plus 0 is 0. -2 plus 0 is -2. And 0 plus 1 is 1. Now the question is, what do I do here? I typically would want to, say, divide this by -3, or maybe swap or something like that. But things are going to be ugly if I do that. I have maybe a sort of a tricky idea. I can instead try to get a 1 here and then get zeros up here, a 1 in the lower right and zeros up here, and then finally try to get a 1 here and zeros above and below. So let's multiply or divide row 3 by -1 so as to get a 1 here. And what I end up with there is, this is sort of playing around with the elimination algorithm. So long as the steps you use are valid row operations, you can do whatever you want. 1, 1, 1, 0, 1, 0, 0, -3, -2, and 1, -2, 0, and then 0, 2, 1, 0, -2, 1. It's hard to write small with a thick pen like this. Okay, now I want to get a 0 here and a 0 here, so I'm going to add -1 row 3 to row 1 to get a 0 here. I'm going to add 2 row 3 to row 2 to get a 0 here. I'm going to do the arithmetic kind of quickly here. So when I subtract row 3 from row 1, 1 minus 0 is 0, 1 minus 2, excuse me, 1 minus 0 is 1, 1 minus 2 is negative 1, 1 minus 1 is 0. That's what I wanted. 0 minus 0 is 0, 1 minus negative 2 is 3, and 0 minus 1 is negative 1. With row 2, I am adding 2 times row 3. I get 0 plus 0 is 0, 4 plus negative 3 is 1, 2 plus negative 2 is 0, 0 plus 1 is 1, negative 4 plus negative 2 is negative 6, and 2 plus 0 is 2. The bottom is 0, 2, 1, 0, negative 2, 1. Okay, great. Now I've got zeros here. That's what I wanted. Finally, I've got a 1 here. I want to get a 0 here and a 0 here. So now I'm going to add row 2 to row 1. I'm going to add negative 2 row 2 to row 3. And what this gives me is, again, doing the arithmetic kind of fast. When I add row 2 to row 1, I get 0 plus 1 is 1, 1 plus negative 1 is 0, 0 plus 0 is 0, 1 plus 0 is 1, negative 6 plus 3 is negative 3, 2 plus negative 1 is 1. The middle stays the same, 0, 1, 0, 1, negative 6, 2. And the bottom becomes 0 plus 0 is 0, negative 2, I'm going to add negative 2 row 2 to row 3, so negative 2 plus 2 is 0, 0 plus 1 is 1, negative 2 plus 0 is negative 2, 12 minus 2 is 10, and negative 4 plus 1 is negative 3, so that means that my inverse is this guy on the right. What I'm about to shade in blue, that is my inverse. So then the final step here is to go ahead and multiply this against the vector that's on the right. But the problem is the vector on the right is different depending on what the values of k are. So for step 2, well, the first thing the book says to me is, let's solve this one. k1 is equal to negative 6, k2 is equal to negative 10, and k3 is equal to negative 3. So what do? I take the inverse, and I will multiply it against the vector with the matrix with these components. 1, negative 3, 1, 1, negative 6, 2, and negative 2, 10, negative 3, and I multiply that against negative 6, negative 10, negative 3. I'm going to do the multiplication here a little bit faster, but again, it's this times this, plus this times this, plus this times this. 1 times negative 6 is negative 6, negative 3 times negative 10 gives me plus 30, and 1 times negative 3 gives me minus 3. 1 times negative 6 is negative 6, negative 6 times negative 10 gives me plus 60, and 2 times negative 3 is also negative 6. Negative 2 times negative 6 is 12, 10 times negative 10 is minus 100, and minus 3 times minus 3 is plus 9, and this works out to be 30 minus 6 is 24, minus 3 is 21, 60 minus 6 is 54, minus 6 is 48, and 12 plus 9 is 21, and 21 minus 100 is equal to 70 minus 79. Let me just check my answer here. It's very possible that I messed something up. It looks like I probably did mess something up here. Let me just check that I got the right matrix inverse, because that's a possibility of where I messed things up. And again, you can probably find a matrix inverse calculator someplace online. So let's see. Yeah, I completely messed this up. Not entirely sure where I went wrong, but I totally got the wrong matrix inverse. In any case, That's what I get for trying to go through the matrix inverse calculation a little bit too quickly. Um, yeah. But what's the point here? The point here is, let's pretend that I got the right answer. After I do this, the book then gives me a couple of different values for k. So it then gives me k1 is equal to -7, k2 is equal to 0, and k3 is equal to 9. Well, I already found the inverse. So to find the answer for part B, I just have to multiply the inverse against -709, and I get my answer. And again, I did the wrong inverse, so, I really do have more work to check. I would have to recompute the inverse. But then finally it gives you, another example. K1 equal to 2, K2 equal to -4, and K3 equal to -1. Dun, dun. And again, I would take the inverse here and multiply it against 2, 4, -1. And I get whatever the answer is. So once, my whole point here is once you find the inverse, parts A, B, and C of the problem are just multiplication. Matrix multiplication, but multiplication nonetheless. So that's all you have to do. The last two parts are just straightforward. I'm assuming there's two more parts, just 3 total parts. There might be a fourth part. Let me just check for kicks. Yeah, that's it. So they're just 3 parts. All right.